Let's talk a little about symmetry, because symmetry can come in awful handy sometimes when various analytical approaches for different problems you may be working on. Now, we say that a graph is symmetric with respect to, and WRT is, if you haven't seen it yet, is a very common notation for with respect to. So a graph is symmetric with respect to the y-axis if for every xy on the graph, that implies that there exists a negative xy on the graph. And if you draw a quick picture, that really makes a lot of sense. Because if this is xy axis, and right here I have some point that, let's say, is on some graph that I'm dealing with, and this has coordinates xy. Well, symmetric about the y-axis means that this point here has exact same coordinates over here, or relative. So I'm the same distance away, and I'm the same height away. Well, this is going to have this coordinate x. This is going to have the same distance. So this would be a negative x, and it's the same height, so it's y. So this must be a negative xy. So that's really all that means. So something like a quadratic function, like x squared, the entire function would be symmetric about the y-axis. Likewise for something like negative x squared. Both these is in fact symmetric about the y-axis. Now we say a graph is symmetric with respect to the x-axis if for every xy on the graph, then we have an x negative y on the graph. Well, again, if we draw a quick picture, that will make a lot of sense, I think. So here's the xy axis, and here's some point with coordinates xy. Well, if it's symmetric about the x-axis, then I need to go this same distance down here and put the point. So, it's symmetric about the x-axis. Well, what's the coordinates here? If it's the same distance, then I'm at a negative y here, but the same x. So this is x negative y. So a function, or actually it's not a function, but we can come up with an equation like this. Something like that would be, in fact, symmetric about the x-axis. Now, a graph is symmetric with respect to the origin if for every xy on the graph, that means I'm going to have the point negative x, negative y on the graph. So again, let's draw a quick picture here. Of course, right there's the origin. So over here, I have an xy. If I'm symmetric about the origin, and then what I have is this distance right here, an angle. I'm not going to talk about angle specifically, but I think you get the same idea. I think you get the idea. It's going to be over here. See, here's symmetry. It reflects around, or a mirror image about the origin. Well, what will these coordinates be? If this is x, this must be a negative x. And if that's y, then this must be a negative y. So this has coordinates negative x, negative y. Now, that brings me to the idea of even and odd functions. Now, we say that f is an odd function if f of negative x is equal to a negative of f of x. And in other words, this thing is symmetric about, or with respect to, the origin. Now, f is an even function if f of negative, erase that real quick, f of negative x is equal to f of x. Now, a couple quick examples. Consider f of x equals x squared. Now, is that an odd function, an even function, or neither? Well, to find out, I'm going to say, well, what is f of negative x? Now, f of negative x equals a negative x squared, which is positive, that's x squared. Therefore, f of negative x is equal to f of x, that is an even function, which is symmetric with respect to the y-axis, which we could see if we did a quick graph of this. X squared looks like this. And this is, in fact, symmetric with respect to the y-axis, and it's an even function. Now, a quick example of an odd function, f of x equals x cubed. Well, f of negative x equals a negative x cubed, which is negative 1 cubed times x cubed. That's a negative x cubed, which is in fact a negative f of x. X cubed looks like this. And okay, I didn't do a really good job of drawing up, but I'm sure you get the right idea. So if I have this point here, xy, then let's make this xy, then over here is the negative of x, negative y. So this is symmetric about the origin. Let's try, take a look at one more real quickly here. Let's see. How about f of x equals 1 over x? Okay, well, f of negative x will equal 1 over a negative x, which equals a negative 1 over x, which is a negative f of x. Therefore, f of x is in fact odd. And if you draw the function, if you do a quick graph of f of x equals 1 over x, you know that the function looks like this. And again, you can clearly see that this is in fact symmetric about the origin. Now keep in mind, all functions are not either odd or even. Any given function may not be odd or even. So if you're asked to take a look or determine if a function is odd or even, don't think that it will absolutely be an odd function or an even function. It could very easily be neither.